having a area of 3 square centimeter and normal opening produces 2 centimeter of leaflet separation. You see the 3 casts. This is the RCC, this is LCC and this is NCC. Remember the one with interatrial septum, near the interatrial septum is the NCC. LCC সবসময় LA appendage এর দিকে থাকে. This is the LA appendage, right? LCC is closer to the LA appendage and NCC is near the IS. Okay. Now this is bicuspid. See? Bicuspid aortic valve. Can you see? Yes. And look at the number of cusps when the valve leaflets are opened. Not during line of closure, because often there is raphe which gives an appearance of a leaflet. So, and have you seen this valve? You have seen before?
No.
So, quadricuspid, right? Now tell me where from the turbulence is coming. Look at this first. Here the turbulence is coming from the valvar level, see? Right? Valvar level. And look here. In the morning we got a case where there was a subvalvular aortic stenosis. See here, there is a membrane here. Have you seen?
It is subvalvular supravalvular.
And the valve is here. So it is subvalvar aortic stenosis. And look here. Look here. Where is the stenosis? Valve is here.
Supravalvular.
Yes, turbulence is coming from. So this is supravalvar aortic stenosis. You need the color flow to differentiate between valvar, subvalvar and supravalvar stenosis. So when we do the Doppler assisted, we look at velocity, pressure gradient, valve area by continuity equation and dimensionless index. Have you learned all this? Okay. So to look at the valve velocity and gradient is very easy. There is severe calcific aortic valve stenosis. I went to the apical 5-chamber view, made the flow parallel to my cursor and got the CW Doppler. I trace it. As I trace it, I get peak velocity, peak gradient, mean velocity, mean gradient and VTI. These are the 5 things. Okay. Next, which view we will use to get the maximum gradient? We will use all the views. Our aim is to get the highest possible gradient. Which are the views? 5-chamber, 3-chamber, suprasternal, right parasternal and subcostal. Wherever you are getting the gradient, keep the record and then use. Right? And which gradient is to see? Peak or mean? Mean, yes. As per the latest guidelines in 2017, it is the mean gradient which classifies mild, moderate, severe, right? Less than 20 is mild, more than or equal to 40, mean gradient is severe.
What about the normal bicuspid as
Yes.
well as bicuspid? They are similar.
Normal velocity is 1.4 plus minus 0.4. So the gradient should be less than, actually velocity wise, velocity should be less than 2.5 centimeter per second. এটাতে দিয়েছে এখানে আমরা অটোস্ক্লেরোসিস বলি। So the gradient, আমরা gradient দেখো না, velocity if it is less than or equal to 2.5 meter per second, we will not say it is stenosis. We will say autosclerosis. Clear? And we will দেখুন এখানে কিন্তু gradient কিছু দেয় না। তার মানে কি gradient মিনিমাল 16, 17 এইসব আসবে। আমরা যদি এটাকে 4v স্কয়ার করি, ঠিক আছে? ওকে। তো এই জায়গাটাতে মাইল বলবো আমরা, মিন রেডিয়ান ক্লিয়ার। এটা কি পড়াবো পড়ানো হয়েছে কন্টিনিউটি ইকুয়েশন অডিট ভালভ এরিয়া পড়ানো হয়েছে
প্রজেক্টরটা একটু এদিকে সরাই দেন, এদিকে সরাই দেন।
প্রজেক্টরটা
ছোট করার একটু।
area by continuity equation main principle is what goes in must come out. Whatever flow is going through the LV outflow tract should cross the aortic valve also. Okay, so what is the formula? Stroke volume at LV outflow tract is equal to stroke volume across aortic valve. Stroke volume কেন করছি? এই যে এই কথাটা what goes in must come out, so whatever flow in the alveoli should be flow in the aortic valve across the aortic valve. So flow across a valve is the stroke volume, right, across LVOT or across aorta. So what is the formula of flow across a valve or LV outflow tract? It is the area of that site into VTI. এগুলো পড়েছো তো তোমরা হেমোডাইনামিক্সে পড়েছো? হ্যাঁ পড়েছো। আর এখানে স্ট্রোক ভলিউম অ্যাক্রস aortic valve area into aortic valve VTI. Now we know that for our convenience aortic valve, any valve or LVOT is considered to be circle and we measure the area by measuring the diameter. Clear? Diameter. So LVOT, this is the formula. Stroke volume পড়েছো তো, এগুলো তো অটোমেটিক চলে আসে। আচ্ছা, into LVOT VTI, aortic valve area into aortic valve VTI. So aortic valve area will be whole thing divided by aortic valve VTI. তাহলে আমাদের এখানে কি কি মেজার করতে হয় দেখো, ডিটা মেজার করতে হবে, LVOT VTI মেজার করতে হবে, and aortic valve VTI measure. Not a big deal. We can measure the diameter. How do we measure the LVOT diameter? এটা কিন্তু লেটেস্ট গাইডলাইন্স এর ছবিটা, রাইট? আগে একটা কনফিউশন ছিল আমাদের অ্যানুলাস আর LVOT ডায়ামিটার কোথায় মাপবো কোনটা। এখন দেখো এখনকার পিকচারে কোনো অসুবিধা নেই। অ্যানুলাস ইজ ফ্রম দ্য হিঞ্জ পয়েন্ট টু দ্য হিঞ্জ পয়েন্ট, আর LVOT is within 1 centimeter, within 10 millimeter, right, from the annulus, and it should be measured in the mid system. Clear? So this is the LVOT diameter. এই যে anterior leaflet যেখান থেকে শুরু হলো ওখানে লোয়ার পয়েন্টটার উপরে। Clear? Annulus is from the hinge point to the hinge point. Annulus measurement and the LVOT diameter measurement is not same. একটু ডিফারেন্স আছে। Excuse me. So, see, aortic valve area measurement by continuity equation is very easy. Only you have to go through 3 steps. Step 1, step 2, step 3. In step 1, you measure the LVOT diameter. So, 1 number হচ্ছে parasternal long axis, 2 number হচ্ছে you have to zoom the view. Zoom. And then you measure the LVOT. Aortic annulus is somewhere here within 10 millimeter. I have measured and it comes out to be 2.3 centimeter. Step 1, shesh. Step 2, you go to the apical 5 chamber. Apical 5 chamber, put the color flow and then color flow যেই দেবে LVOT দিয়ে ব্লাড যাচ্ছে aortic valve দিয়ে, aortic valve এর থেকে উপরে inside the LV cavity, LVOT যেটা, ওখানে স্যাম্পল ভলিউম বসিয়ে পালস ওয়েভ ডপলার করতে হবে। সো LVOT পালস ওয়েভ ডপলার, অ্যান্ড দেন ইউ মেজার দ্য VTI। যে কোনো VTI মেজার করতে হলে ট্রেস করতে হয়। হোয়াট ইজ VTI? It is the integration of the entire velocity. Okay, so integrate করতে হলে you will have to cover the area under the curve. So LVOT VTI is 19.8 centimeter. Next, in the same view, you will keep the cursor in the same position and you will do the CW Doppler. This time you are picking up the gradient across the aortic valve. Like It is a case of stenosis, so there will be some gradient. Look at the aortic valve VTI, it is 96.6 acute. So the formula is diameter square into this value, pi এর value আছে হলো LVOT VTI, we know the LVOT VTI, we know the aortic VTI, so aortic valve area turns out to be 0.85 square centimeter. Now look at the AEC guidelines. Aortic valve area less than 1 severe, more than 1.5 mild, 1 to 1.5 is moderate. So my case is severe aortic stenosis. Clear? And then next, an important thing is the dimensionless index. Dimensionless index. Dimensionless index. See? এটা ভীষণ ইজি, এটা হচ্ছে গিয়ে এলভিওটি যে aortic valve এরিয়া যেটা করলে তোমরা তখন এলভিওটি গ্রেডিয়েন্ট বাই পালস ওয়েভ ডপলার নিলে তো এলভিওটি ভিটিআই aortic valve ভিটিআই নিলে ওই এটা নিয়েই এলভিওটি ভিটিআই ডিভাইডেড বাই aortic valve ভিটিআই রেশিও বার করবে। নর্মালি ইফ x amount of blood is passing through the LVOT, it should cross, X amount should cross across the aortic valve. In presence of aortic stenosis, it will be less. How much less? In severe, ratio will be less than or equal to 0.25. In moderate, 0.25 to 0.5. And in mild, it's more than 50. More than 0.5. So in this case, dimension VTI, this VTI divided by this VTI, dimensionless index is 0.2. So it's severe. Should I start? Congenital heart disease a bit.